On today's episode of Soliverse, we are diving into strategies for scaling solar worldwide, comparing business landscape and engineering in both Germany and India, and exploring thermal energy solutions and AI's role in solar design and management. Please enjoy. Hello and welcome to the SolidWorx Podcast. My name is Peter Pongracz and I'm joined here by Michael Zapf of Heliocraft. Michael, welcome to the show.
Thank you very much, Peter. Thank you for the warm welcome, and I'm glad to be here.
Excellent. So where should we get actually started? So maybe if you can give the audience a quick introduction about yourself, the company, and what is the angle that you are actually taking in the solar business.
Yes. So, well, let's say maybe we start a bit with my personal background. Actually, I'm a lawyer by training. I also have a degree in business administration, and after a short but successful career in lawyering, I decided that I want to start my own company. That was around 3.5 years ago, and at that time, solar was ramping up its wave and its impact on the world. And so in the end, I went into the energy business to start Heliocraft. And I also wanted to do something that is like a bit leaving an impact on the world. Not something that will just make me money. Of course, making money is an important part of every business, and I'm not saying that I have purely altruistic motives, but I also wanted to do something that would make sense for me, for society as a whole, but also for future generations.
Excellent. And we actually discussed prior to the show about leaving more for the future generations than we actually consume, right? That's
Yes.
a really good angle to dive into the deep. If you are looking at Heliocraft as a company, what makes it stand out in the solar space?
So what we try to do is we not only try to place modules on roofs or on fields, but we try to provide 160 degrees energy solutions, interconnected and intelligently managed. Just putting panels on roof, I think that's something that most people can do and learn very quickly, and that's an important part of it as well. But I think the most value can be generated by integrating it smartly with consumers of energy, with other methods of generating energy, especially with things that create thermal energy. I mean, we not only consume electrical energy, we also consume a lot of thermal energy. So there is this German word that's very, very nice. It's like a typical German word. It's called Sektorenkoppelung. In English, it would mean sector coupling. So that's something we're very actively trying to do to give to businesses, to our clients, to communities, a energy solution that not only considers electrical energy or solar, but that will give a 160 degrees fulfillment of their energy needs.
Makes sense. So you're actually taking a more holistic approach of providing the whole system and providing a solution that's fully end to end. It's quite interesting because most companies try to focus on one niche, either on the EPC side or the battery side or connecting it to the grid. So that's quite refreshing. And if we can talk a little bit more about the markets that you are focusing on. So you are based in Germany, but I heard that you have some pretty interesting plans into scaling globally.
Yes, that's correct. So we recently opened a engineering office in India, and we're also entering the Indian market to do the same things that we do in Germany, mainly develop, plan, project, build, and operate energy power plants. And I very strongly believe that India is a great market, and I see a huge potential there. And actually, I also like the country very much, and I'm always happy to be there. And I think that was a right step for us. Then we also are trying to expand Europe-wide. At the moment, we are mainly based in Germany. Our core market is Germany, but we are working very hard to expand to Eastern Europe. We recently opened a subsidiary in Croatia and planning to do projects there. And we also think Romania and Bulgaria are very interesting markets. So we are trying to expand our reach and trying to bring clean energy solutions to everybody that raises their hand.
Excellent. I mean, I guess if there is the market, you better grab the opportunity. And I can only echo the Croatian and Romanian side as well. We crossed paths in the past in a similar setting, and Romania obviously is one of the last bastions where you don't really have that much solar developed yet. And from my experience as well, you have really good engineers in Croatia as well, which cover both West and Eastern Europe as well. So that's a great move, and I cross my fingers for getting it as successful as possible.
Thank you very much.
From on the project level, we discussed a couple of interesting projects before this recording. You spoke about a couple of projects that you are excited about. Can you give the audience a little bit more insight into that?
Well, actually, we have two projects that excite me very much in the long term. One of them is that we are trying to build a e-mobility charging park for trucks, not so much for personal vehicles, but really for electrical trucks. And we're trying to do this as self-sufficiently as possible. So what we are trying to aim for is to have a big ground mount solar power plant. We have a big battery system that acts as a buffer battery. And we have a high voltage megawatt charging system that caters to the trucks. And the thing is that usually if you have this kind of setup, you would have the ground mount system would have an inverter that converts the direct current to alternating current. And then the battery system would have a power conversion system that would take the alternating current, transform it back into direct current. Then when somebody comes to charge, we will take the direct current from the battery, transfer it to alternating current, and then feed it back at the charging point, transform it back to direct current, and then charge the direct current into the truck. So what we're trying to aim for is to have a system in place that will operate with a direct current bus system, meaning that you don't have this many conversion systems that are happening, which greatly increases the efficiency of the whole system and loss through the transformation processes. So that's I think that's something that's fairly new. I know that there are a couple of systems up and running that already do the combination of charging, solar, and battery. But at least to my knowledge, as far as I know, nobody is doing it with a direct current bus. So that's something that we that we are very much looking forward to develop this and put this project in place. And the second project I'm very excited about. It's still in the early phases, so it's still a bit uncertain, but that would be a facility of a big charity in Germany that's housing mentally challenged people. And the facility was built in the 50s, so their energy system is really, really outdated. They still have oil heatings. They have a very old grid. And what we're trying to do is to install a combination of a ground mount solar park and a fifth generation near district heating and cooling system, meaning that we will have interconnected with the ground mount power plant. We will have a heat pump, a big heat pump, a central heat pump, and we will have a ice storage facility. I'm not so sure if Peter, do you know what's an ice storage facility? I'm not even sure if that's the correct English term.
I roughly know, but maybe if you can unpack that for the audience, that would be great.
Okay, so basically, it's a big tank in the ground filled with very normal water, drinking water, and I mean that would now need a small foray into the physics of thermal and thermodynamics. So basically, what is heat? Heat is just movement of atoms. So you have this water molecules that are like shaking, and but if water turns to ice, meaning at this point between the phases from a solid to a liquid, the movement of the atoms rapidly stops, meaning that making water to ice, that's super counterintuitive, but making water to ice actually frees up a lot of energy. There is a physics term that's called crystallization enthalpy. I hope I get the words in English right. If not, I'm deeply sorry.
We will link them in the
German, it's another nice German word. It's called Kristallationsenthalpie.
Okay.
That's something that the German language is very good at doing. This long words that sound very complicated. So basically, getting water to ice frees up a lot of energy, more or less the same amount of energy that you would need to heat water from 0 degrees Celsius to 80 degrees Celsius. So, and that amount of energy can be used by the heat pump as a energy reservoir, so to speak of. And that energy reservoir is tapped in by actually icifying the storage. So what's happening is that during the winter, where you heat a lot, the water will turn into ice, and then during the summer, you will turn the water back in the ice back into water, and you have recharged your heat storage.
So essentially, the principle is similar to having a battery pack in a sense.
Yes. Just for thermal. It's like a form of thermal storage. So you have like a thermal battery, more or less. I mean, there are some other concepts, but this ice storage is something it's also not completely new. It's not like here this was invented yesterday. So this principle has been around for the better part of 2 decades, but it's not so widely used. mainly because it's a bit complicated to set up, and big heat pumps has not yet been something that was so widely available in the past 2 decades. So it's just ramping up now. But from the different possibilities of storing thermal energy, I think that's a big one because it does not require so high temperatures. I mean, another possibility to store heat would be just heat up sand. There is a startup in Finland actually that's doing that. They got some very interesting results, but then you are talking about something that's like 500 degrees Celsius hot. And that's much harder to handle than just basically water and ice. So and it puts a lot more stress on material. So I think at least for like let's say residential use where you don't need that high energy or high temperatures, I think ice storages will be the thermal storage to go, and not so much something like sand or high temperature storages.
Indeed, and I think all of these technologies, of course, they as you drive up on the production side and scale into economies of scale, of course, the price will come down, and of course the technology refines as well. So it's going to be more accessible to more people, and then it's not going to be only applicable for the industrial scale type of projects, but also maybe for the residential as well. But I'm super excited about the both actually, both the ice and also the sand one. The sand one I did quite a lot of research in, and I hope to have the guys on the show in the near future. I think it's super cool, and that's an interesting solution.
Yes, I also think I think they're doing a great job. I've been watching them for a while now. I've never been in touch with them, but I've been watching their progress for a while now, and I think they're doing a great job. And there are some really great startups with a lot of bright people and a lot of bright ideas to in this field, to actually get this field of thermal storage off the ground, which I think will be a very important component of the energy transition to renewable energies, because storing heat is just so much easier and cheaper than actually storing electricity. So I think that's a super important part in the whole Sektorenkoppelung.
That's a nice German word.
Yes, of the whole energy system of the future.
Oh, but that's very cool. And we've talked about the projects you are excited about, but maybe if you can dive a little bit deeper into some of your biggest failures as an entrepreneur and what you have learned from them.
Well, I had a couple of startups before Heliocraft during the time. So the idea to start a company was not the end, but it was more or less the beginning, and everything else was just something that to further that plan. So I had a couple of tries. I tried to start an e-learning platform. That's almost 10 years ago, actually. After I graduated from university with my degree in law, I wanted to start an e-learning platform to help people prepare for the bar exam. But that failed spectacularly because we could not get all the content in place rapidly enough that we and in the quality that we were envisioning. Then I had a startup that was basically around 2017, 18, that was dealing with the financing of building projects. We thought we had a very good solution for banks to reduce their risk, but well, the bank thought otherwise. So that was like a clear market mismatch between our idea, which we thought was very bright. And I think on an academic level, it probably was, but like in practical, none of the banks were having it. So that's more or less failed in the initial phase. Before we got it even off the ground and started funding. Then I had a couple of years as a lawyer, and then with Heliocraft, I mean, we had a quite a big, failures there as well. The biggest problem that we had initially to actually get all the grid connection done, because we had people from early on that could do the, let's say, direct current side of our projects, but we had a lot of trouble finding people that would actually deal with the grid connection side, so everything that's after the inverters. In the end, we really did a lot of research, and together with two of our engineers, we wrote a Bible on grid connections. So that's something now we can very easily do and solve. But that was a hard problem, and the first projects, they were a nightmare to connect to the grid. But that's something that's we got a lot better.
But that's also something that many companies are still struggling with. So if you have overcome that already, then that's already a huge step in the right direction.
Yes, no, we're very happy. But initially, this was a nightmare, and we tried to find subcontractors for this, and we had a few over the projects, but with none of them we did more than one project because it was always such a horrible experience. So in the end, we decided to have this in-house and do this ourselves completely, which has been a journey, quite a lot, I must say. And that journey is still ongoing, but I think we're now in a much better position than we've been 12 months ago dealing with this. But this, from all the problems we had to solve, this was probably the one that we chewed the most on, and that was the most also the most humiliating for us, that to get this off the ground. And
But you actually triggered a couple of things inside my mind as well. You touched on the HR side of things, so difficulty of having to find
yes.
qualified and good people, especially in solar. Right, we are in a quite niche of a business, and I've seen the Solar Power Europe report of solar potentially doubling in workforce in the next 10 years, which is quite a challenge. Where do you think these people will come from?
Well, that's actually a huge problem, and also one that's keeping me up at night, because we really have a hard time to find qualified electricians and engineers in the whole electrical space. Moving to India, that move that we discussed earlier a little bit, was to a big part also motivated by this, that we were in the position that we really needed more engineering power, more planning power to get things off the ground. So that was a big part of our strategy to solve our HR and workforce issues. That was actually a move in the right direction. We found incredible engineers over there. Then we moved almost all of the planning to India. So that worked out, but still on boots on the ground, you still need to have them. And I cannot legally get so many Indians as I want into the country. So that's still a huge problem. And to answer your question, I honestly have no idea where people will come from. I think that will be a huge problem that will only increase and increase. So we either will drastically change the immigration policies, especially in Germany, but in Europe as a whole, to address this issue and get qualified people into the country, or it's not going to happen. I think that's one of the two major risks that are faced by the solar industry or renewable energy industry as a whole in Europe. The first one being we don't have enough qualified people. The second one being an extremely one-sided reliance on Chinese manufacturers for modules and power electronics, inverters, and so on. So that is another thing that's probably be a challenge in the future.
But I guess for you as a business, what we are really talking about is inputs into the process, right? So on one side, you have the engineers. On the other side, maybe we can talk a little bit about the tooling itself as well. So what kind of software tools do you use to develop these projects, and how that helps you in terms of gaining some efficiencies there as well?
Software tools are super important in our process. We do all our planning with VirtuCAD. That's a Belgian company, and we're very happy with them. That gave us a lot of efficiency, and they're not as expensive as their competitors. I might add, some of their competitors really have insane prices that were prohibitive as a startup for us. So, and we're very happy, and we've grown pretty close with the people there. And I think that was a big help, and is a big help in making things more efficiently. Another thing that helped us a lot is the usage of drones. So from every project, we make a 3D image using photogrammetry, and use this 3D image as a basis for our planning, especially for big rooftop projects. That's also something that we're constantly faced with to get things more efficiently. So that's something that we work a lot on. Now I'm working on systems that are even making things more accurate than photogrammetry. I mean, with a photogrammetry drone, you can get up accuracies up to, let's say, 10 centimeters if you do everything very good. But after that, it gets hard to get things more accurate. So what we're now checking out is things like LiDAR, and to find a cheap solution there. It's been on my agenda for quite some time. I've now, when I started out, I found solutions, or most of the solutions I found were like beyond the 30,000 euro range for one system. Now we're more getting into the like 2,000, 3,000 euro range. So that there is a huge price drop in available system that are also available for usage. So at the moment, there are some offers that you can already buy fully functional LiDAR SLAM systems for under 2,000 euros. So that's something that's been a lot of help, this price drop. And I'm pretty sure that if we roll this out, we will decrease the cost further and increase the accuracy as a planning base. So that's something I'm working a lot on. And there is this new technology in the 3D space. It's called Gaussian splatting. It's like it would go into too much detail to explain how it works. And to be honest, I not fully understand how it works. It works with neural networks. That's that's what I understood, and it potentially allows you. At the moment, they still have a bit of trouble to get all the measurements true to the real world, but at least the technology has the potential to get accurate and lifelike 3D digital twins of buildings, so that we have a further improved planning basis. So my vision is that we at some point we have like a status or the ability to basically send one guy with a drone and a handheld scanner onto the site, and then we have like a 3D digital twin that everybody in the world can use as a planning basis, and everybody basically has the same information as somebody who would be on site. So it's just a vision, but basically I can have my engineer in India put on a 3D goggles, and he will be more or less seeing the same thing as somebody that's on the site. Of course, that's a vision that's not yet a reality, but that would be something that we're working on to further reduce friction, to further reduce the time for the planning, and to further reduce also time on site, because if you have everything planned out, things on site go a lot more smoother.
Indeed, and I can only echo that. Everybody's looking for one connected workflow, right? So everybody just wants to have their work done as efficiently as possible within one ecosystem. And coming back to the drone side, I will actually put you in touch with my friends at SiteMark. They are a really, really cool drone company covering all stages of the life cycle. So that's going to be very useful. But on the design side of things, I hear this over and over again, that everybody is quite tired of having a disconnected workflow. First you fly the drone with one company or even manually, then you move into the design phase, you design your a power plant in software X, then you need to export the yield into PVSys, and then you need to move on to operation. So this is quite a challenge, and I think that it's the next $1 million opportunity to create a really open ecosystem where you can at least connect different providers via an API. So an EPC or project developer such as yourself can move along the whole life cycle of the project.
That would be so awesome to have, and that would be a real game changer, because actually the story also goes on. I mean, you have this many like disruptions in the engineering space from a EPC point of view, but I mean that's only part of the life cycle, right? So you have basically you have the whole like customer relationships managing process in like getting the people on board with the project, developing the project, getting all the permits, the grid connection permits, and so on. And then you go into the design phase, and then you you have these different stages of design, like doing a preliminary design to get the customer on board to make an offer, then have the like detailed design, which basically is everything. Then you have the communications design between the SCADA system and the inverters, and you have like a million different design jobs that are, some of them are automated, some of them are not automated, some of them are covered by tools like AutoCAD, some of them are not covered. For example, the whole like communications space, which is increasingly important, and which is also something that will increase in the future as grids are getting more smarter and smarter. And then, but then you also have the space of actually operating the power plant, meaning that you need to control it, you need to operate in all the details, you need to fix things, you need to gather data around it. And so everything is in different silos. So especially the operating side is like a completely different silo at the moment than the engineering side, but you also need a lot of data from the engineering side. So to have an integrated system that's basically covering the life cycle of a power plant, not only solar, every power plant, or from cradle to grave, basically, that would be something that would be a real game changer. I mean, if somebody is looking for a business idea and wants to join this, please hit me up. I have a lot of ideas and plans laid out. I just don't have the time and the resources at the moment to do this myself. And it's I rather be focused on Heliocraft and its business model. But if somebody is listening to this and feels like, okay, that's something I want to start on myself, please reach out. Because I really think that this is something that's going to change the industry by a lot. And I think there's a huge opportunity to have this interconnected software that really deals with all aspects.
Indeed. And I think, you still need to move into the digitization of all aspects of the whole value chain as well. Yes. And this is going to be a huge game changer with AI. You've touched on it as well. But speaking of AI, where do you see the biggest contribution of AI to solar?
I see two main areas. One opportunity I see in actually designing stuff, aid design. I mean, there's already a lot that happened there with algorithmic processes that will automatically create module layouts or cabling paths, and that's already working pretty well. But I think that there's some improvement to be had with using AI supported design methods. So meaning that we can basically ask the AI to identify suitable areas on roofs, for example, or identify suitable cable paths in buildings. I think there's a lot of potential that's at the moment basically done manually. And the second, and I think in the end, more impactful AI application in the energy world is actually steering an integrated energy system. I mean, to elaborate a bit further, so we talked a lot about this amazing German word called Sektorenkopplung, sector coupling. And in the end, in the sector coupling, you need to have some sort of control function, probably something that's centralized, that will tell the heat pump, okay, now it's a good time to heat, because at the moment the energy from solar is super available. and maybe it's better to not make the heat pump work, but store the energy in a battery, because the weather will be warm in the foreseeable future. So you will predict you will not have so much need for heating. I'm just making examples up. So there are like a lot of like optimization decisions that are only increasing in complexity. So I mean, at the moment we talk about a fairly basic system, like we have a solar. Actually, it's not that basic anymore, but I mean, we have like a solar power plant that's generating energy. Then we have like a heat pump that's creating heat. Then we have like an ice storage facility that's used as an energy reservoir. Then we might have a thermal buffer, or we might also have a high temperature storage for. Then we have an electrical storage in form of a battery, and then we have the heating grid, the district heating grid, that's also a buffer in itself. And then we have like demand predictions, like when how much energy is being consumed over the next 24 hours, 1 week, something like this. Then we have a prediction about the weather, so how much solar will be available. We have a prediction about how much heat energy I will need. And you see, you can spin this, and that's just a basic setup. So if you add things, if you add consumers, if you add more ways of producing, add a small wind farm, medium-sized wind farm into a system like this, things get exponentially complex in their optimization. Then we can imagine, I mean, everything is like getting more complex. So I think steering this increasingly complex system of different components and different predictions, and will be a task that in the end only can be handled by some sort of machine learning and AI algorithms. That's not something you can do. Well, definitely it's not something you can do on a human scale. The time where somebody sits in a chair with a lot of screens in front of them and pushing buttons and rerouting energy is definitely over, but it's also increasingly not solvable by traditional algorithmic means. I'm pretty sure that will be the biggest impact of AI in this field, to actually control interconnected systems.
Indeed, and I think the more data we have, we actually have a twofold challenge: having not enough data and having too much data. But I think if AI continues like this, then I think it's going to be beneficial to rather have too much data, and we will actually know what to do with it. So on the analysis side, it's going to be definitely a huge step forward.
Yes, definitely.
And we talked about AI and production as well. One of the biggest unmet needs in Europe is production, right? And if you want to enable this new production, it's going to be, we will need exponentially more energy here. Where do you, or what do you see the market like in Europe in terms of manufacturing, let that be modules, inverters, etc.? And where do you think that's heading?
Well, maybe we start with a quick look into the past. I mean, once Europe, also Germany, we were like the first movers in terms of manufacturing equipment for solar, especially modules. But then, for some reason, we lost out to the Chinese, that basically took over and are absolutely dominating the solar world. I mean, I'm not aware that there is any meaningful module producer in Europe. Right now, there are some niche producers, but like somebody that's really producing modules in a large scale. At least I don't know any of them. Definitely not in the multi-gigawatts per year capacity range. So basically, at the moment, we're super dependent on the Chinese manufacturers for everything, which is a big geopolitical risk in my eyes. We have traded the dependency on energy suppliers from the states that supply oil and gas to the dependency on Chinese manufacturers for our energy infrastructure. We basically just exchange one pressure point against another pressure point. And I mean, setting up our own value chain ecosystem for producing the things in Europe is a lot more easier than creating gas and oil somewhere, or finding gas and oil somewhere in Europe, because one, you can actually have an impact on, the other one you cannot. So we really need to do this. And I mean, I'm a person with a very liberal mindset, and if you would have asked me 5 years ago, I would have said that this is insane. But at least in this critical markets with critical infrastructure, I strongly believe that we should have a Buy Europe First policy, the same as Indians and probably the USA at the moment, how things are
something
developing.
Similar to the IRA that they push, but we will see what will happen with that in terms of the new presidency of Trump. So
yes, so I strongly believe that we have to reignite module manufacturing and the whole eco system and the whole value chain. We have to reignite this in Europe. We cannot be left out or left dependent on China for this. What I believe is like one of the most crucial things in the coming future for our energy systems.
And I guess we are in the same boat with the batteries as well, right? In terms of lithium, both mining and refinement. It's I think the latest data was something like 80% is done by China, and well, to put one lithium mine online, it takes about 7 to 8 years, and we haven't even started a refinery. So
yes,
that's also another challenge.
Yep. And we're too slow in doing this kind of things. And I mean, with all the things that are happening in the world right now, and with all this increased in geopolitical instability, we really should get our asses off the ground in Europe to at least see that we're not depending on, let's say, unreliable partners for at least the most crucial things of our society. I mean, nothing would shut off our society as a whole than a widespread grid collapse. So or the ability to not further increase our energy production capacities. So that's something that's is a choke point for us and a big vulnerability. And also that we get so much of our critical infrastructure in terms of inverters and transformers, which are increasingly also smart and cloud connected, which in a sense is a good thing. But then also I mean, think about if there is a backdoor in all those inverters that are produced by China and installed in German homes and factories. I mean, if there really would be a back door. I mean, basically, we create a red button for the Chinese military to send it back to the Stone Age with one push of a button. Because, I mean, if even 10% of the inverters in Germany would turn on and turn off at the same time, it would completely destroy grid stability. So basically, we would be left in the Stone Age if ever something like this would happen. So it's also not only a matter of like who has the best prices or who has the best manufacturing processes, but also it's a big part of, I mean, energy infrastructure is a big part of our combined European security system. And I don't think that we should rely on actors that may or may not be hostile to us too much for this really most fundamental parts of our society.
Indeed, indeed. I mean, we kind of dug a hole here, and it's going to be quite difficult to get out of it. But I hope we can do it. I firmly believe so. But yeah, and when we are talking about the global context, you guys just scaled into India. How do you see the difference in terms of corporate culture, doing business? What are the main pluses and minuses between Germany and India, for example, in terms of working in solar?
Well, I hope I will not get a lot of complaints from my German engineers and employees, but in general, Indians are super motivated and work super hard. I mean, we have great people in Germany as well that are working really, really very hard. I don't want to diss anybody here. But I think the corporate culture in India is a lot stricter with the work ethics. So they are really staying late, burning the midnight oil. They are a bit more hierarchical in terms of they will ask you to verify decisions a lot more than a German employee would. A lot of people warned me before I made the move to India that they are like, you have to give them clear processes and they will not do anything by themselves. I don't. I cannot confirm this. Maybe in other places it is, but I see a lot of initiatives and very good ideas of our Indian employees. So I was in China for an exchange program for 1.5 years in the year 2007, 2008. And they had at that time, China had this massive energy of like, okay, we're moving forward, we're developing everything, had like at least 3 side hustles to make money, to advance things, and everybody was like, oh, now is our age coming, we will make we will catch up to the West. We will become a great society again, and we are developing economical, and everybody was like focused on making things work and get things into motion. And now when I came to India for the first time last year, I had the same feeling of energy. Everybody is there, very motivated. They want to put things into motion. They want to move forward. They want to create things. They want to make a better life for themselves. And I think that creates a very good basis for the economic growth, this motivation, this positive outlook, which I have to say we are desperately lacking in Europe. in Europe, everything is, oh, that's a big problem. Oh no, we cannot do this. Oh no. We're always no, and they're always more like yes. Yes, let's do this. Yes, let's go forward. And in Europe, we're always, oh, that's a huge challenge. Oh, I don't think it will work out. Oh, but that's what I love about India. They don't have this like pessimistic outlook on the world, and also the Indian government has big plans. I mean, China had the fastest growing capacity of solar production in the world. They're adding 100 plus gigawatt peak in capacity per year, and India is a bit driven by fear of missing out. They're planning to add at least 300 gigawatt peak in the next 5 years. That's the national plan. So theirs will be also a huge growth and a huge opportunity for us to be part of that growth.
Yeah, indeed. And I mean, last year I was putting some sales plans together for global expansion, and of course, the two major markets that you can actually penetrate is the US and India in terms of new capacity being added. It would be amazing to break into China as well, but that's a whole nother game.
Yes. I mean, even though I've been to China and I have great connection in the country, I thought long and hard about it, but in the end, I decided against it, and decided to roll with India, as I saw more potential there, and also a little bit because China, I have the feeling, is a bit more close to foreigner that it was before. So I have the feeling that the climate of doing business there has decreased a bit. So in the end, we decided to go with India. But it's also something that would be really awesome to actually expand into the Chinese market. But if I see an opportunity, I will definitely take it. But at the moment, I'm not seeing that the stars are aligning right for this.
Of course, and when we are looking ahead, what are the things that you're most excited about in terms of solar for this year?
For this year, that's a good question. For this year, I think, I mean, solar is rapidly becoming one of the cheapest forms of producing energy, especially when combined with battery storage systems. And I think we will this year and next year we will see a huge wave of battery installation for to balance out the let's say skewed side of solar production, like and to even things out for also for the grid stability, but also we have too much solar during noon, we don't have enough during the night, obviously. So I think the most exciting things at the moment is to master the integration of batteries into the grid system, and also to master the integration of batteries into solar production systems. So I think that's the thing that in the next, if I would say this is the most exciting thing that's like happening right now in the next 10 months until the end of 2025, I would say probably the integration of batteries into the various systems to and then after this, looking out, I strongly believe that we will see new new technologies in terms of solar modules that I'm very excited about, but that are still like 3 to 4 years out. Especially Fraunhofer in Freiburg, they are working on a couple of very super interesting technologies. In this regard, I very strongly believe that we will see in like 3-4 years a completely new generation of solar modules. And well, I think solar is here to stay. I mean, the age of fire is, in my opinion, is over, and the age of solar has begun, and it will be here until it will be replaced by something even more cheap and reliable, probably fusion. But at least in my opinion, that's like there is this joke about fusion that it's always 50 years in the future. That's been 50 years ago, and it's still 50 years in the future. So if not somebody makes a lucky break, it's probably still 50 years away. So at least the let's say the first half and probably also the second half of the 21st century will strongly belong to solar in terms of energy generation. So I think that's the thing that excites me most, and it will integrate into everything. We will see a lot of smart solutions where solar will be integrated in buildings, in factories, as a building component. So I think there's a lot of exciting stuff ahead.
Amazing. And speaking of the fire part, what would be the book that you would recommend to anybody to read?
There actually, well, I would. There is one. There was one special edition of The Economist that was a couple of months ago that I would recommend everybody to read. It's called The Age of Solar. I hope I get the title right.
We'll link it in the show notes.
And that's something I would highly recommend everybody to read, because it really showcases the importance that solar will play in the future. And people that are really wanting to go deep in the whole thinking about energy and the impact of energy on our society game, there is one author that I would really very highly recommend. His name is, he is a professor in Canada. His name is Václav Smil. I hope I pronounced this right. Pronouncing things wrong is kind of my thing. And the book is called Energy and Civilization, and he really traces from the beginning of the human age. He traces back to the modern times, the impact energy had on the human development, and the close interconnectedness between energy and civilization. So every time we manage to unlock a new and cheaper source of energy, we made a huge development jump as a society as a whole. And I think that if we manage to drive prices of energy down with solar on a global scale, it might actually pave the way for a new era that is fueled by even more cheaper energy that's abundant and renewable. So I mean that's like deep philosophical questions, but
Yeah.
I mean, if you see this pattern of every time we unlock a new and cheaper source of energy, we make a huge jump. So if we master solar, and with solar can produce an abundance of cheap energy on a global level, I strongly believe that we can also master the new steps as a civilization, whatever that might be.
Yeah, that's a great answer. But we will definitely link to those in the show notes below. And if you had an ask to the audience, what would be the 1, 2, 3 things you would be looking for Heliocraft as a company?
Well, that's a good question. I mean, what I really be looking for Heliocraft would be more awesome employees. I mean, we have a really great team, but as we said before, getting people on board is it's not the most easy task because there are not so many fitting people available. Well, and then I really would be looking forward that we could be one of the companies that is like driving the transition to clean and renewable energy in the like systemic sense, meaning that not only solar but all the other forms of energy, and that we will be a company that's highly invested into research and development, and trying to push the boundary, what's like the current state of how to do things a bit further in the right direction. I think that would be the thing that would make me really proud, that we could be like somebody that say, okay, now we've managed to overcome this and that challenge, and people are actually copying it. I mean, it sounds maybe a bit counterintuitive to say, okay, I want people to copy me. But I would,
Then you're
there
at the
would be
front of
no
the pack.
higher honor than people would copy the things that we do. And that means we did something right and they think that what we did was good. And that would be something that would I find very awesome. And in this, just grow as a company, grow as a community of like-minded people, and we play a big part in the transition, and to leave a better planet to our children that we have gotten from our parents, and especially leave them a planet where that's worth living in and that's at ease living in, not leave them a desert wasteland. That would be a big plus. And no,
that's what we are trying to make sure that we avoid.
Yes.
And last question, Michael, where would be the right way to reach you? What would be the best place to reach you?
Well, you can always send me an email. I'm not stingy with my email address. You can link it in the show notes. If somebody wants to get in touch, please do so. And if you're in Munich, just hit me up. I'm always happy to have a coffee, or you just drop by in our offices. And always happy to meet new people, always happy to expand my network. And somebody has some exciting projects for us to work on, I would be also very happy to do this.
Amazing. And I guess Intersolar is just around the corner, so we'll catch up there as well. But without further ado, Michael, thank you very much for your time. Michael Zapf from Heliocraft, and looking forward to meeting you again in person.
Likewise, I'm very happy to see you for Intersolar, and we keep in touch. Thank you very much for your time and to listen what I have to say.
Thank you. I'm stopping now.